There are moments in human history when everything changes in an instant. When a single observation, a single measurement, a single data point forces us to reconsider everything we thought we knew about our place in the universe. August 15th, 1977 was one of those moments. For 72 seconds, a radio telescope in Ohio detected a signal so powerful, so precisely structured, so mathematically improbable, that the astronomer reviewing the data 3 days later grabbed a red pen and wrote a single word in the margin. Wow! That word, scrawled hastily on a computer printout at 1:15 in the morning, became the name by which this signal would be known forever, the WOW signal. In what we uncover here, please take a moment to like this video and subscribe to the channel. Your support helps us continue bringing you the latest developments on 3 Atlas as they unfold in real time. The most compelling evidence humanity has ever detected for the possibility of extraterrestrial intelligence. And also one of the most frustrating mysteries in the history of astronomy, because the signal appeared once for 72 seconds and then vanished. It has never repeated. Not in the 48 years since that August night. Not despite hundreds of attempts to find it again. Not despite thousands of hours of telescope time dedicated to scanning the same patch of sky. The WOW signal came, announced itself with impossible clarity, and disappeared into silence. Tonight, as you drift towards sleep, let me tell you the story of those 72 seconds. The story of what we heard, what it might have meant, and why after nearly half a century we still don't know whether we detected the first confirmed message from another civilization, or witnessed some bizarre natural phenomenon we've never seen before or since. This is a story about patience and frustration, about hope and uncertainty, about the profound loneliness of listening for a voice in the cosmic dark and hearing, just once, something that might have been an answer. The Big Ear radio telescope sat in a flat field outside Delaware, Ohio. It wasn't the largest radio telescope in the world. It wasn't the most sophisticated. It was built on a shoestring budget by Ohio State University, using surplus materials and volunteer labor. The primary reflector was constructed from aluminum panels mounted on a wooden frame. The whole structure measured about the size of 3 football fields. It couldn't move or point at different parts of the sky. Instead, it relied on the Earth's rotation to scan across the heavens, slowly sweeping its field of view through the cosmos as our planet turned. This fixed design meant the Big Ear could only observe any given point in the sky for a maximum of 72 seconds before Earth's rotation carried that point out of the telescope's field of view. 72 seconds. That's how long you had to detect anything interesting. Anything that lasted longer than that would be cut off. Anything that appeared after the telescope had moved on would be missed entirely. The universe had to cooperate with your observing schedule, not the other way around. Despite these limitations, the Big Ear was participating in one of the most ambitious projects in human history. It was searching for extraterrestrial intelligence, listening for radio signals that might indicate the presence of technological civilizations elsewhere in the galaxy. This was SETI work, the search for extraterrestrial intelligence, and in 1977 it was still a relatively new field, controversial, exciting. Viewed by some as the most important scientific endeavour humanity could undertake, and by others as a waste of time and resources chasing fantasies. The Big Ear didn't have astronomers sitting at the telescope every night, watching data stream in real time. Instead, it recorded observations automatically. The telescope scanned the sky continuously, and every few days someone would print out the data and review it manually, looking for anything unusual. This was pre-digital era, pre-internet. The data was printed on continuous feed computer paper, those long sheets with perforated edges and alternating white and green bars. Each page showed intensity measurements for different radio frequencies across different time intervals. Mostly the printouts showed noise, random static from Earth's atmosphere, from terrestrial radio interference, from the background hiss of the universe itself. But on August 15th, 1977, something different happened. The Big Ear was pointed toward the constellation Sagittarius, sweeping through a region of sky near the border with the constellation Scorpius. The telescope's receivers were tuned to a narrow band of frequencies around 1420 MHz. This frequency is significant. It's close to the 21 centimeter line, the frequency at which neutral hydrogen naturally emits radio waves. Hydrogen is the most abundant element in the universe, Any civilization with radio technology would know about the 21 centimeter line. It's a universal constant, a natural frequency that stands out against the cosmic background. If you wanted to send a signal that other technological civilizations might notice, you'd broadcast near the hydrogen line. It's like ringing a doorbell that anyone with radio telescopes would recognize. At approximately 10:59 p.m. Eastern Time, the Big Ear's receivers detected a signal at precisely 1420.456 MHz. The signal was strong, extraordinarily strong. It started weak, grew rapidly in intensity, peaked, and then declined as the telescope's beam swept past the source. The pattern matched exactly what you'd expect from a point source in space being observed by a fixed radio telescope as Earth's rotation carried it through the beam. The signal lasted for the full 72 seconds that any point source would be visible to the Big Ear. And then, as the telescope's field of view moved on, the signal disappeared. The signal strength was measured and recorded automatically. The Big Ear used a simple alphanumeric system to represent signal intensity. Blank spaces meant no signal. Numbers 1 through 9 represented increasing signal strength. Letters A through Z represented even stronger signals. The printout from that night showed the signal's intensity progression. 6, E, Q, U, J, 5. Let me decode that for you. 6 means a signal 6 times stronger than the background noise. E, being the 5th letter, means a signal 15 times stronger than background. Q is the 17th letter, meaning a signal 27 times stronger. U is 21, meaning 31 times stronger. J is 10, meaning 20 times stronger. And then 5, meaning 5 times stronger as the signal faded. This pattern, 6EQUJ5, traced a perfect bell curve. Exactly what you'd expect from a radio source rising into the telescope's beam, reaching maximum intensity at the beam's center, and then declining as it passed out of view. 3 days later, on August 18th, astronomer Jerry Ehman was reviewing the printouts. This was routine work. Scan the pages, look for anything unusual. Most nights produced nothing interesting, but when Ehman reached the data from August 15th, he stopped. His eyes fixed on that sequence, 6EQUJ5. He recognized immediately what he was seeing. This signal was strong, narrow band, at a significant frequency, with a pattern consistent with an extraterrestrial point source. He grabbed a red pen and circled the sequence. Then he wrote in the margin, in hasty capital letters, "Wow!" It wasn't a technical assessment. It wasn't carefully considered scientific notation. It was pure, spontaneous reaction, an exclamation of surprise and excitement and disbelief. Because Jerry Ehman understood the implications. If this signal was real, if it was extraterrestrial, if it was artificial, then humanity had just detected evidence of another technological civilization. We were not alone. The universe was not silent. Someone, somewhere, had built a transmitter powerful enough for us to detect across interstellar distances, and they had broadcast at a frequency that suggested they wanted to be heard. But there was a problem. Actually, there were many problems. The first and most immediate problem was that the Big Ear only had one receiver operating that night. The telescope had 2 receivers, which normally scanned 2 adjacent patches of sky simultaneously. This redundancy was built into the system specifically to help confirm detections. If both receivers saw the same signal, you could be confident it was real, and not some instrumental artifact or terrestrial interference. But on August 15th, only one receiver was operating. So there was no immediate confirmation, no second data stream showing the same signal, just one isolated detection. The second problem was that nobody was monitoring the telescope in real time. The signal was discovered 3 days after it occurred, when Jerry Ehman reviewed the printouts. By that time, Earth had rotated many times. The telescope had scanned across that same region of sky multiple times since August 15th. But the automatic recording system wasn't sophisticated enough to trigger alerts. It just recorded everything and waited for human review. So there was no opportunity to immediately repoint the telescope, no chance to call other observatories and say, "Look at this right now." The third problem was the most frustrating. When the team realized what they'd detected, they immediately began follow-up observations. They pointed the Big Ear at the same region of sky. They searched for the signal again. They observed for hours, for days, For weeks. They enlisted other radio telescopes to help search. They came back to that spot repeatedly over months and years, and they found nothing. The signal never repeated. That patch of sky, those coordinates in Sagittarius, remained stubbornly silent. Whatever had produced the WOW signal on August 15, 1977, either stopped transmitting or was no longer pointed toward Earth, or had been a one-time event that would never occur again. This is where the story becomes both fascinating and maddening. Because the WOW signal has all the characteristics we'd expect from an extraterrestrial transmission, but it also has characteristics that make it extremely difficult to interpret or confirm. Let me walk you through what we know, what we don't know, and why this 72-second detection has remained one of astronomy's greatest mysteries for nearly half a century. Start with the frequency. 1420.456 megahertz. This is incredibly close to the hydrogen line at 1420.406 megahertz. Close enough that it's clearly in the waterhole, the region of the radio spectrum between the hydrogen line and the hydroxyl radical line at 1612 megahertz. This region is called the waterhole because hydrogen and hydroxyl combine to make water, and the name suggests a place where different civilizations might meet on the electromagnetic spectrum. It's relatively quiet, with minimal natural background noise. It's protected by international agreement from terrestrial radio transmission. It's the frequency band where many SETI searches focus their efforts, because it's where you'd broadcast if you wanted to be heard across interstellar distances. The signal's narrow bandwidth is also significant. Natural radio sources like pulsars or quasars produce broadband emissions across a wide range of frequencies. But the WOW signal was extremely narrow band, less than 10 kHz wide, possibly much narrower than that, limited by the Big Ear's frequency resolution. Narrowband signals are characteristic of artificial transmitters. When you tune a radio to a specific station, you're tuning to a narrow frequency band where that station broadcasts. Natural cosmic radio sources don't work that way. They spray radio energy across huge swathes of the spectrum. The narrowness of the WOW signal suggests technological origin, something designed to concentrate energy at a specific frequency rather than dispersing it broadly. The signal strength is remarkable. At its peak, it was about 30 times stronger than the background noise. To achieve that intensity from an interstellar distance requires either a very powerful transmitter or a very large antenna focusing the beam, or both. Let's think about what that means. The nearest star system to Earth, Alpha Centauri, is about 4.3 light-years away. The region of sky where the WOW signal originated is farther, but let's use Alpha Centauri as a conservative baseline. To produce a signal strong enough for the Big Ear to detect at that distance, you'd need to broadcast with immense power. Some estimates suggest the equivalent power output of a large planetary power grid focused into a radio beam. This isn't impossible. Humanity could theoretically build such a transmitter with current technology if we dedicated sufficient resources. But it would be a major engineering project, a significant investment. Something you'd build if you really wanted to announce your presence to the galaxy. Alternatively, the signal could have come from closer, much closer. If the source was within our own solar system, perhaps a spacecraft or probe of some kind, the required transmitter power would be much lower. But this creates other problems. Why would a spacecraft in our solar system broadcast at the hydrogen line frequency? Why would it only transmit for 72 seconds? Why has it never been detected again? The solar system explanation raises as many questions as it answers. The signal's temporal characteristics matched perfectly with what you'd expect from a fixed radio telescope observing a point source as Earth rotates. The intensity rose and fell in a smooth curve. The duration was exactly 72 seconds, the maximum time the Big Ear could observe any given point. This pattern argues against many terrestrial explanations. A signal from Earth-based interference, like an aircraft or satellite or ground transmitter, wouldn't follow this specific pattern. It wouldn't rise and fall in a perfect bell curve corresponding to the telescope's beam pattern. It wouldn't last exactly 72 seconds and then stop. The temporal characteristics strongly suggest the signal came from space, not from Earth. But here's where things get complicated. The precise location of the signal's origin is uncertain. The Big Ear's two receivers, when both operating, would scan two adjacent regions of sky separated by about 2 degrees. Since only one receiver detected the WOW signal, we know it came from one of two possible locations, but we can't be certain which. Both locations are in the constellation Sagittarius, near the Teapot asterism that marks the direction toward the galactic centre. One possible location is at right ascension 19 hours 25 minutes, declination negative 26 degrees. The other is at 19 hours 28 minutes, same declination. That's a small patch of sky, but it's not a precise point. There are no obvious candidate stars in either location that stand out as likely homes for transmitting civilizations. This positional uncertainty has hampered follow-up efforts. You can't point a telescope at a single star and wait for the signal to repeat. You have to search a region of sky covering multiple star systems, and you have to hope that whatever transmitted in 1977 is still transmitting and is pointed toward Earth and is operating at the same frequency. That's a lot of assumptions, and so far none of them have been validated. Every search has come up empty. The lack of repetition is the WOW signal's most frustrating characteristic. In science, extraordinary claims require extraordinary evidence. A single, unrepeated detection isn't conclusive. It's suggestive, intriguing, worth investigating, but not proof, not confirmation. For the WOW signal to be accepted as genuine evidence of extraterrestrial intelligence, it needs to repeat. Other observatories need to detect it. Multiple independent confirmations need to establish that yes, there is a radio source at this location, broadcasting at this frequency, with these characteristics. Without repetition, the WOW signal remains an anomaly, a data point that doesn't fit our models but doesn't conclusively prove anything either. Why might a signal not repeat? There are many possible explanations. Perhaps it was a beacon that sweeps across the galaxy like a lighthouse beam. We happened to be in the beam for 72 seconds as it swept past, and we won't be in the beam again for months or years or decades. Perhaps it was a one-time transmission, a deliberate message sent once and not repeated. Perhaps it was an accident. A powerful transmitter briefly pointed in our direction unintentionally before being redirected. Perhaps the civilization that transmitted no longer exists. Civilizations rise and fall. Stars have lifetimes. 450 light-years away, a civilization might have existed in 1977 minus the light travel time. They might have transmitted. They might have fallen silent. We might be hearing their voice from the past, from a civilization that's already gone. Or perhaps the explanation is more mundane. Perhaps the WOW signal wasn't extraterrestrial at all. Perhaps it was some bizarre natural phenomenon, a previously unknown type of stellar flare, a burst from a pulsar we haven't identified, an interaction between cosmic rays and the interstellar medium that produced a brief, narrow-band radio pulse. Weird things happen in the universe. New phenomena are discovered regularly. The universe is stranger than we imagine, stranger than we can imagine. Just because we don't know of any natural process that produces narrowband radio pulses at the hydrogen line frequency doesn't mean such a process doesn't exist. Or perhaps it was terrestrial interference after all. Perhaps an aircraft or satellite or secret military transmitter briefly reflected or transmitted a signal that appeared to come from space. The problem with this explanation is that the signal's characteristics don't match typical interference. The frequency was in a protected band. The temporal pattern matched what you'd expect from a celestial source. The signal strength and narrowness are unusual for common interference sources, but unusual doesn't mean impossible. Earth-based explanations can't be entirely ruled out without more data. The most significant attempt to explain the WOW signal as a natural phenomenon came decades later, in 2016 and 2017. Astronomer Antonio Paris proposed that the signal might have been caused by a comet. Comets have hydrogen-rich atmospheres. When a comet is far from the Sun, its hydrogen can extend in a large cloud around the nucleus. If Earth's line of sight passed through this hydrogen cloud, the hydrogen might emit radio waves at 1420 MHz, and since comets move, the signal would be transient. You'd detect it briefly as the comet passed through your telescope's field of view, and then it would be gone. Paris identified two comets that were in roughly the right region of sky in 1977. Comets 266 P/Christensen and 335 P/Gibbs. These are faint comets, not discovered until much later, but their orbits placed them near the WOW signal's coordinates in mid-1977. Paris suggested that one of these comets could have been the source. To test this, He observed the comets during their later passages near Earth, looking for hydrogen line emissions, and he detected some emissions, though much weaker than the WOW signal. This comet hypothesis generated significant media attention. Headlines proclaimed the WOW signal solved after 40 years, but the astronomical community was skeptical. The emissions Paris detected from the comets were far weaker than the original WOW signal. The spectrum was broader, not the narrow band signal originally observed. And there are other problems. Thousands of comets pass through various regions of sky. If comets routinely produced WOW signal-like emissions, we'd see such signals frequently. But we don't. The WOW signal remains unique. Furthermore, the specific comets Paris identified weren't confirmed to be in exactly the right position at the right time. The hypothesis is interesting but not conclusive. Many researchers continue to doubt that comets can explain the signal, so we're left in limbo. 48 years after Jerry Ehman wrote "wow" in the margin of a computer printout, we still don't know what the signal was. We have more questions than answers. Was it artificial? Was it natural? Was it even real, or some instrumental artifact we don't understand? The uncertainty is maddening. But it's also, in its way, appropriate, because this is what searching for extraterrestrial intelligence actually looks like. Not the clean narratives of science fiction, not the dramatic first contact scenarios of Hollywood films, but ambiguity, patience, frustration, the painstaking work of gathering data, analysing it, trying to distinguish signal from noise, genuine phenomena from artifacts. Let me tell you what makes the WOW signal so emotionally resonant, beyond its scientific significance. It represents hope and disappointment in equal measure. For 72 seconds, we might have heard another voice, another civilization, proof that intelligence exists elsewhere, confirmation that we're not alone in the universe. That's profound. That would change everything. Our place in the cosmos, our understanding of life's prevalence, our sense of isolation or connection. For 72 seconds, all of that seemed possible, seemed real, seemed confirmed. And then silence. The signal never repeated. Follow-up searches found nothing. The tantalizing possibility faded into uncertainty. We're left holding a printout with 6 letters and numbers circled in red pen, wondering whether we glimpsed something extraordinary or were fooled by some mundane phenomenon we don't understand. That emotional arc from hope to uncertainty to resigned mystery is central to the SETI experience. This is what it means to search for extraterrestrial intelligence. You listen, you wait. Sometimes you think you hear something, and then it's gone, and you're left wondering. The WOW signal changed SETI in important ways. It demonstrated that transient signals are possible, that you might detect something briefly and lose it before you can confirm it. This realization led to improvements in detection systems. Modern SETI projects use real-time analysis. When something interesting appears, alerts are triggered immediately. Other telescopes can be notified within minutes or hours, not days. Observations can be coordinated globally. If something like the WOW signal appeared today, the response would be faster and more comprehensive. The signal also highlighted the importance of follow-up observations. One detection, no matter how compelling, isn't enough. You need repetition, confirmation, multiple independent verifications. The scientific process requires reproducibility. The WOW signal, for all its remarkable characteristics, remains scientifically unconfirmed because it can't be reproduced. This lesson has shaped how modern SETI projects evaluate potential detections. Initial excitement must be tempered with caution. Verification must precede announcement. The field learned from the WOW signal that anomalies happen, and not all anomalies indicate extraterrestrial intelligence. Perhaps most importantly, the WOW signal reminds us that the universe can surprise us. Before August 15th, 1977. No one had detected a signal quite like it. After that night, we knew such signals were possible, even if we don't know what caused them. The universe expanded slightly in our understanding. We learned that narrow-band radio signals at the hydrogen line frequency can appear from regions of sky with no obvious sources. Whether that's mundane or profound remains to be determined. But the possibility exists, the data exists, the mystery persists. Jerry Ehman, who discovered the signal, remained cautiously agnostic about its origin until his death in 2022. He acknowledged it could have been extraterrestrial. He also acknowledged it could have been something else. He resisted the temptation to claim definitive knowledge either way. In interviews, he emphasized that without repetition, without confirmation, we simply don't know. And that uncertainty is okay. That's science. You live with ambiguity. You admit what you don't know. You keep searching. The Big Ear radio telescope was demolished in 1997 to make way for a golf course expansion. The decision was controversial. The telescope had operated for decades. It had contributed valuable data to SETI and radio astronomy, but funding had dried up. The university needed the land. The telescope's last observations were in 1998. Today, a memorial marker stands near the site where the Big Ear once listened to the cosmos. The marker includes a representation of the WOW signal printout, 6EQUJ5. Those characters are immortalized now, symbols of humanity's brief potential contact with another intelligence. Other telescopes have taken up the search: the Allen Telescope Array in California, the Green Bank Telescope in West Virginia. Breakthrough. Listen. A well-funded SETI initiative using multiple facilities worldwide. These projects scan millions of stars across billions of radio channels, searching for signals that might indicate technological civilizations. They've detected many interesting candidate signals, but none have been confirmed as extraterrestrial. None have repeated and been verified. The search continues, patient and methodical, knowing that detection might take decades or centuries, or might happen tomorrow, or might never happen if we're alone, or if civilizations don't broadcast, or if they use technologies we can't detect. The WOW signal remains a cautionary tale and an inspiration. It warns us that detection might be fleeting, that we might glimpse evidence and lose it. That confirmation is challenging, but it also proves that something can happen, that the search isn't futile, that signals, whatever their origin, can reach Earth from space, that our instruments can detect them, that the universe isn't entirely predictable, that anomalies occur, that mystery persists. Sometimes late at night, astronomers still point radio telescopes at those coordinates in Sagittarius, still scan the frequencies around 1420 MHz, still search for a repeat of that 72-second signal from August 15, 1977, 48 years and counting. The silence continues, but the search continues too, because we don't know what we'll find until we look, because the universe might surprise us again, because somewhere in our galaxy civilizations might exist, and if they exist, and if they broadcast, and if their signals reach Earth, we want to be listening. The WOW signal asks a question we can't yet answer. Are we alone? For 72 seconds in 1977, the answer seemed to be no. We seemed to detect proof of another voice, another mind, another civilization. The excitement must have been intoxicating. The implications staggering. First contact, not face-to-face, not dramatic or immediate, but contact nonetheless. Evidence, confirmation, connection across the cosmic void, and then nothing. The signal ended. Follow-up searches found silence. The evidence remained ambiguous. The question returned to its unanswered state. Are we alone? We still don't know. The WOW signal tantalizes but doesn't confirm. It suggests but doesn't prove. It opens possibilities but doesn't close the question. Think about the patience required to search for extraterrestrial intelligence. You point your telescope at the stars. You listen. For hours, for days, for years. Mostly you hear nothing. Background noise, terrestrial interference, natural cosmic radio sources that follow predictable patterns, pulsars ticking away with clockwork regularity, quasars blazing from supermassive black holes billions of light-years away, gas clouds emitting at characteristic frequencies, all fascinating, all natural, none indicating intelligence. You catalogue these sources, you filter them out, you develop algorithms to recognize and dismiss known signals so you can focus on the unknown. You search for patterns that don't match natural phenomena, narrowband transmissions, repeated sequences, mathematical structure, anything that might indicate deliberate construction rather than random cosmic processes. And very occasionally something appears that you can't immediately explain, a signal that doesn't match your catalogues, that has unusual characteristics, that makes you wonder. Your pulse quickens, you check for instrumental artifacts, you verify your calibration, you look for terrestrial explanations. Usually you find one. Usually the mysterious signal resolves into something mundane: a satellite, an airplane, a malfunction, interference from a nearby transmitter. The universe isn't sending you messages. You're seeing noise, artifacts, the busy radio chatter of human civilization. But sometimes you don't find an explanation. Sometimes the signal remains anomalous, and then you face a choice. Do you announce it? Do you trigger follow-up observations? Do you alert other astronomers? The risk is twofold. Announce too early, and you might be wrong. Might cause excitement over nothing, might damage your credibility. But wait too long and you might miss the opportunity. The signal might fade. Other telescopes might not be able to confirm. The moment might pass. Jerry Ehman and his colleagues at the Big Ear made the right call. They documented the WOW signal. They attempted follow-up observations. They wrote papers describing it. They were honest about its limitations while acknowledging its significance. They didn't claim it was definitely extraterrestrial. They didn't claim it was definitely something else. They presented the data and admitted uncertainty. That's responsible science. That's intellectual honesty. That's the appropriate response to genuine anomalies. The public, of course, wanted definitive answers. Was it aliens? Yes or no? The ambiguity was unsatisfying. People wanted confirmation or denial, not uncertainty. But uncertainty is often the honest answer. We don't know. More data needed. Further investigation required. These aren't cop-outs. They're admissions of the limits of current knowledge. Science doesn't always provide immediate answers. Sometimes it provides questions that persist for decades. Imagine being an astronomer in 1977, seeing that printout, realizing what you might be looking at. The excitement, the disbelief, the immediate urge to confirm, to verify, to make sure this is real. And then the frustration of follow-up observations finding nothing. The growing realization that you might never know what that signal was, that you might have witnessed something extraordinary or something mundane, and you'll spend the rest of your career unable to prove which. That's the emotional reality of the WOW signal. For everyone involved, for everyone who studied it since, it represents unfinished business. A mystery that should have an answer, but doesn't. A question that should be solvable, but isn't. A moment that might have been first contact, but might have been a cosmic hiccup. We're left suspended between possibilities, unable to commit to either interpretation with confidence. And yet there's beauty in that suspension, because it keeps the question alive. The WOW signal prevents us from becoming complacent. It reminds us that the universe can surprise us, that phenomena we don't understand can occur, that the search for extraterrestrial intelligence isn't futile because signals can reach Earth, even if we don't know what produced them. The mere existence of the WOW signal, ambiguous as it is, justifies continued searching. Consider the odds. The Big Ear was observing for years. During that time, it scanned across countless patches of sky. It detected millions of data points. Out of all those observations, one 72-second window produced something truly anomalous. One brief moment stood out. If you calculate the probability of randomly observing a signal with the WOW signal's characteristics, the numbers are vanishingly small. This rarity is part of what makes it compelling. If such signals were common, we'd see them frequently, but we don't. The WOW signal stands alone, unique, unexplained. What are the implications if the signal was artificial? If some civilization, somewhere, did broadcast at the hydrogen line frequency, and we happen to detect it, first it confirms we're not alone. That's profound. That reshapes our understanding of our place in the cosmos. We're no longer the universe's only experiment in consciousness. Other minds exist. Other civilizations have arisen. We're part of a broader community of intelligence, even if we can't yet communicate with them. Second, it suggests that radio communication is a viable method for interstellar contact. We've been broadcasting radio signals unintentionally since the early 20th century. Our television and radio transmissions have been leaking into space for over 100 years, creating an expanding bubble of electromagnetic noise centered on Earth. Any civilization with radio telescopes within 100 light years could potentially detect us, at least in principle. The WOW signal suggests the reverse is also true. We can detect them. Radio astronomy works for SETI. The search isn't futile. Third, it raises questions about motivation. Why broadcast? What's the purpose? Are we detecting a deliberate beacon intended to announce a civilization's presence? Or are we intercepting communications meant for someone else? Or are we seeing the side effects of some technology, emissions that aren't meant as messages but that reveal the sender's existence anyway? The answer affects how we interpret the signal and what we might expect from future detections. What are the implications if the signal was natural? If comets or pulsars or some unknown astrophysical process produced it? First, we learn something new about the universe. We discover that natural processes can produce narrowband radio emissions that mimic artificial signals. That's scientifically valuable. It helps us understand cosmic radio sources better. It teaches us about the phenomena that can confuse SETI searches. Second, it warns us about false positives. If natural processes can produce wow signal-like emissions, then detection alone isn't sufficient. We need more stringent verification criteria. We need to be more careful about distinguishing natural from artificial. This doesn't mean SETI is impossible, but it does mean it's harder than we might have thought. The bar for confirmation is higher. Third, it suggests the universe is stranger than we realize, that our catalogues of natural phenomena are incomplete, that new discoveries await, that we should expect the unexpected. This is fundamentally optimistic. It means science isn't finished, that we haven't figured everything out, that mystery and wonder persist, that exploration remains worthwhile. Either way, whether the wow signal was artificial or natural, its existence matters. It's a data point, a fact that requires explanation, an observation that doesn't fit neatly into our models. Science advances by confronting such anomalies, by grappling with observations that challenge assumptions, by refusing to ignore data just because it's inconvenient or ambiguous. The wow signal endures because it embodies both hope and humility. Hope that we might detect extraterrestrial intelligence. Hope that the search isn't futile. Hope that confirmation might come in our lifetimes. But also humility. Recognition that the universe is complex, that our understanding is incomplete, that single observations, no matter how compelling, aren't definitive, that extraordinary claims require extraordinary evidence, and we don't yet have that evidence for the wow signal. As you drift towards sleep tonight, think about those 72 seconds. Think about Jerry Ehman reviewing printouts at 1 a.m, seeing that sequence of characters, 6EQUJ5, recognizing its significance, grabbing his red pen and writing "wow" in spontaneous excitement. Think about the radio waves that traveled across space, carrying whatever information they carried, arriving at Earth on August 15, 1977, being detected by a telescope built from surplus parts in an Ohio field. Think about the chain of coincidences required for that detection. The telescope had to be pointed in the right direction. The receivers had to be tuned to the right frequency. The timing had to align. Someone had to review the printouts and notice the anomaly. Any of those factors could have been different. The telescope could have been pointed elsewhere. The frequency could have been wrong. The timing could have been off by minutes or hours. Jerry Ehman could have missed the signal in the printout, his eyes skipping over it in routine review. The wow signal could have gone unnoticed, recorded but never recognized, eventually lost when the printouts were discarded or archived. We came remarkably close to missing it entirely, but we didn't miss it. We detected it. We documented it. We've preserved it. That printout exists, the data exists, the mystery exists, and it will continue to exist until we find an explanation, or until we detect the signal again. The search continues. Radio telescopes still point towards Sagittarius, still scan frequencies near the hydrogen line, still listen for a repeat transmission that might never come. Astronomers remain patient, hopeful, realistic about the challenges but undeterred by the lack of immediate results. Because this is how discovery works. You don't know what you'll find until you look. You don't know when breakthroughs will occur. Science requires patience, persistence, willingness to continue searching even when results are elusive. The wow signal proves that something can happen, that signals can be detected, that the universe can surprise us, and that alone justifies continued effort. Somewhere in the galaxy, perhaps civilizations exist, perhaps they broadcast, perhaps their signals wash across Earth regularly, but we're not listening at the right frequency or the right time. Perhaps they've been transmitting for thousands of years, and we've only recently developed the technology to detect them. Perhaps the WOW signal was one such transmission, and others have passed unnoticed. Perhaps if we keep searching, keep improving our instruments, keep scanning more of the sky more often, we'll detect signals again, confirm them, establish that yes, we're not alone, or perhaps we are alone. Perhaps intelligence is extraordinarily rare. Perhaps civilizations exist but are too distant, their signals too weak to detect. Perhaps they don't broadcast using technologies we can't intercept. Perhaps the WOW signal was a fluke, a natural phenomenon we'll eventually understand, and the silence of the cosmos is real and permanent. We don't know. We can't know without searching, and so we search. The 72 seconds of the WOW signal represent both a moment and an epoch, a moment when something happened, when data was collected, when an anomaly occurred, but also an epoch in human history, the time when we began seriously listening for other voices in the universe, when we built telescopes not just to observe but to communicate, or at least to detect communication, when we committed ourselves to the search for extraterrestrial intelligence as a legitimate scientific endeavour. That commitment continues, the instruments improve, the techniques refine, the sky coverage increases. Every year we search more stars across more frequencies with better sensitivity. Every year, the probability of detection increases if there's something to detect, and if there isn't, if we're alone, we'll gradually accumulate evidence for that loneliness. Either outcome teaches us something profound about the universe and our place in it. The WOW signal won't be forgotten. It's entered into astronomical lore. It's cited in papers. It's discussed in classrooms. It's referenced in popular culture. Those 6 characters, 6EQUJ5, have become symbols of the search for extraterrestrial intelligence. They represent hope and mystery. They remind us that the universe might not be silent, that other minds might exist, that contact might be possible. Even if that specific signal never repeats, its existence proved something happened. Whether artificial or natural remains unknown. But something reached Earth from space that night in August 1977. Something with characteristics we'd expect from a technological transmission. And we detected it. That's real. That happened. That matters. Close your eyes now. Let your mind drift among the stars. Imagine radio waves propagating through space at light speed. Imagine transmissions from distant civilizations, if they exist, spreading outward in expanding spheres, carrying information, announcing presence, seeking contact. Imagine those waves washing over Earth, most of them undetected, passing through our atmosphere and our bodies without interaction. But some of them, a tiny fraction, encountering our radio telescopes, being captured, being recorded, being analysed. Imagine astronomers working through the night, listening to the cosmos, sorting signal from noise, searching for patterns. Imagine the patience required, the dedication, the hope sustained despite overwhelming odds. Imagine the moment of recognition when something unusual appears, the excitement, the careful verification, the cautious announcement, the follow-up observations, the community of researchers working together to understand what's been detected. This is happening right now. As you sleep, telescopes listen. As you dream, data accumulates. As you rest, the search continues. The universe broadcasts its secrets continuously. We're learning to listen, learning to interpret, learning what's natural and what might be artificial, building the expertise and the infrastructure necessary for eventual detection, if detection is possible. The WOW signal blazed across our awareness for 72 seconds and then vanished. But it left a legacy. It changed how we think about SETI. It proved that transient signals can occur. It demonstrated the importance of rapid follow-up and confirmation. It became a benchmark against which other candidate signals are compared. It inspired continued searching. It kept the question alive. Are we alone? We still don't have the answer. Perhaps we never will. Perhaps the universe will keep its secrets. Perhaps the silence will continue indefinitely. Or perhaps tomorrow, or next year, or in a decade, another signal will appear. Strong, narrow band, at a significant frequency, repeating, confirmed by multiple observatories, undeniably artificial, undeniably extraterrestrial. And then we'll know, the search will end, the question will be answered, we are not alone. Until then, we listen, we wait, we search, we remember the WOW signal, and what it taught us about possibility and patience. We honour the 72 seconds when something extraordinary might have happened. We keep the telescopes pointed skyward. We analyse the data. We publish our findings. We train the next generation of searchers. We persist. Because somewhere in the galaxy maybe someone is listening too. Maybe they've detected our radio transmissions. Maybe they're wondering if we're intelligent or just natural radio sources. Maybe they're debating whether to respond, whether to send a signal powerful enough for us to detect. Maybe that signal is already travelling toward us, crossing the light years, getting closer every second. Maybe in our lifetimes it will arrive, and we'll detect it, and we'll know. Or maybe not. Maybe we're alone. Maybe intelligence is unique to Earth. Maybe the universe is vast and old and empty of other minds. Maybe we'll search forever and find nothing. And that's okay too. That's an answer, that's information, that tells us something profound about our place in the cosmos, about the rarity of consciousness, about the preciousness of the one world we know harbours life. Either way, the search has value. Either way we learn. Either way we participate in something larger than ourselves. The quest for knowledge, the exploration of the unknown, the human drive to understand. These are fundamental to who we are. The WOW signal represents that drive, that curiosity, that refusal to accept ignorance when investigation is possible. Sleep now, knowing that the questions persist, that mystery remains, that the universe might surprise us again. Rest in the vastness of cosmic time and space, comfortable in the knowledge that whether we're alone or accompanied, we exist, we wonder, we search. We're the part of the universe that asks questions, and that's remarkable. Regardless of whether anyone answers, the WOW signal endures. 72 seconds, 6 EQUJ5, a moment when we might have heard another voice, or when we encountered some natural phenomenon we don't understand. Either way, a moment that matters, a moment that changed us, a moment that reminds us to keep listening. Good night, fellow searcher. The cosmos is vast, the questions are profound, the search continues, and you're part of it simply by wondering, simply by caring, simply by looking up at the stars and asking, are we alone? That question, and our willingness to seek its answer, might be the most human thing about us. Rest well. Dream of radio waves crossing the void. Dream of civilizations among the stars. Dream of the moment someday when we finally know. The 72 seconds that changed everything, or changed nothing, but gave us hope that someday we might hear clearly what we thought we heard faintly that August night in 1977. The WOW remains, the wonder persists, the search goes on.